Good morning, students. After multiplexing, we will continue with the next topic, that is modulation. So, in case of waves or communication through wireless medium, we need a mechanism called modulation for low frequency waves. For low frequency waves. Now, why do we need modulation? What is the motivation behind modulation is when low frequency waves need to travel longer distance, their strength decreases. Strength of signal decreases. So what happens is when low frequency signals travel longer distance, their strength decreases. Okay, so these are the key things that you need to remember. Why we need modulation? For modulation purpose, why do we need to modulate a wave is if low frequency waves travel longer distance, their signal strength gradually decrease. So they may die. They may not reach the destination itself. Therefore, we need a support of a carrier wave. So what comes into picture? Carrier wave comes into picture. What is a carrier wave? Now, carrier wave is a wave that carries the information signal. Okay. So signal consists of two components. One is carrier wave, another one is information signal, okay, or information wave. So both these waves need to be combined so that the frequency which is low, that can be normalized so that they can travel over long distances and they can ultimately reach their destination. So our goal is to enable the low frequency wave to travel from source to destination through long distances. Okay, so that's why the merging of an information signal along with a carrier wave which enables us to travel long distances without losing its signal is called modulation. So what is modulation? Modulation means encoding information signal along with carrier wave in order to enable the signal to not lose its strength, to travel long distance and ultimately reach its destination. Okay, so that is what modulation is. Now, modulation can be applied on digital signals and analog signals. So such modulation is called digital modulation, and modulation applied on analog signals is called analog modulation. Okay, we will look into each of these in detail now. So first we will start with analog modulation. Modulation can be done based on few properties of the signal. What are the general property of the signal we have studied till now? That it has frequency, it has amplitude, it has its own phase, it has its own bandwidth. Okay, so these are the usual, it has its own wavelength. Okay, so these are what the property of the signals are. So based on few of these property, we can apply modulation. Digital modulation is applied on digital type signals and analog modulation is applied on analog signals. Okay. So now analog modulation can be carried out based on properties called frequency, then we have phase, then we have amplitude. Okay. So we will study first analog modulation. So I will just a quick revision. What is analog signals? See, analog signals are signals whose amplitude continuously varies with time. Okay, somewhat like this. The amplitude varies continuously with time. Okay. Now, what is digital signal? The amplitude varies stays constant for a finite number of time and in limited number of time, we can say at particular time the amplitude varies. Suppose this is the amplitude for this amount of time. At this point there is a sharp drop, that is amplitude varies, the amplitude changes at certain point of time. Then it may be seen, then it may be changing for a certain amount of at a certain point of time. This is T1, this is T2. So at abrupt or random time, or we can say at specific time, whatever may be the case, there is a sharp drop in, or we can say there is sharp change in amplitude in case of digital signal. It is not continuous. Okay. In this case, the change of amplitude with time is continuous. Okay. So in analog, there is continuous change of amplitude with time, and in digital, there is abrupt change. And at a particular interval, or we can say at particular time, there is, the amplitude varies, not continuously. Okay. So this was about analog and digital signal. So what are the types of analog modulation we will discuss now. Okay. So analog modulation is of two types. One is amplitude modulation. Second is frequency modulation. The third one is phase modulation. So the modulation based on the property of amplitude is called amplitude modulation. When we modulate the signal with the information signal with the carrier wave in terms of frequency, we call it frequency modulation. When we do this in terms of phase, we call it phase modulation. Okay. So let's start with amplitude modulation. Suppose this is your carrier wave. Okay. And this is your, suppose, this is your information signal, low frequency signal, we can say. It cannot travel on its own, it needs a carrier. And the merging of carrier and encoding of information signal with carrier, this is carrier, that is called modulation. Okay, this is information signal. Now when we modulate, combine this, the amplitude modulation looks like this. I'm just drawing the outline first. Okay. So this is how the modulating signal look like. This is just the outline, this is not the signal. So if I draw it again, it looks like this. So I'm unable to draw it properly. So somewhat like this. So this is just the outline. The signal is like this. So according to the carrier, the information signal behaves. Okay. This is just the outline. Okay. So I may try once again. So this is how each signal look like. Okay. Then gradually increase as per the carrier. This is how the signal looks like. Okay. As per the carrier amplitude, the information is encoded. Okay. So I think this is sufficient for you to get the idea how modulation takes place, how combining of two signals based on amplitude is taking place. Okay. Next is frequency modulation. Now this happens as per frequency. Okay. Based on the property of frequency, we will now modulate the two signals. Okay. We will merge the two signals. happens in frequency modulation is, suppose the information signal is like this and the carrier signal is like this. Okay. Now what we have to do? What happens is, in each time, whenever in each phase the frequency is changed, the frequency becomes changed. At times it remains like this, at times it remains like this. It depends upon how we code it. At at the upper, this volt we may change, or this volt we may change. Suppose I am taking information signal at this stage and carrier for this stage, then how it will look? This will look like this, then this, then this, then this, then this, then this. This is the modulated signal. Okay. Whenever carrier has up phase, then we take the information frequency. When the carrier has negative volt, that is negative, when this, suppose let's say this is 1, this is 0. Let's codify this. This is 1. Whenever we phase 1, we take the frequency of information signal. Whenever we have 0, that is whenever we get the carrier value of 0, we take the carrier frequency. Okay. So this is called frequency modulation. Okay. Now coming to phase modulation. Phase modulation is also similar. This is same as phase modulation, but it is according to the current value. Phase modulation is applied when the current source is AC, alternating current. Okay. We need to give power. The device needs to have supply of power in order to transmit signals, whatever the signal may be, analog or digital. When the nature of power source is AC, alternating current, then we will use phase modulation. Whenever the current changes its phase, the frequency is changed. So now we can say, in case of phase modulation, suppose whenever change is happening, here a change is happening, then that is here 1, then 0, 1, then 0. This can be said as an AC current. When AC current works like that, we can say at 1, we may take the frequency of information channel. When it is out of phase, that is 180 degree out of phase, then we can say we have to take the frequency of carrier. Then again, it is 1, that is 0 degree. Then we have to take this. When it is 180 degree out of phase, then we have to take the frequency of carrier wave. So this way it alternates. In case of whenever there is a phase change, we may take up the frequency of information wave, and then again when phase changes, we may take off the frequency of carrier. So there is an alternate change in frequency of carrier and information in case of modulated signal. The modulated signal at 0th phase will take information frequency. At 180 degree out of phase, it will take what frequency? The carrier frequency. So this way the frequency alternate. So this is what about this was all about analog modulation. Okay. Now we will go through the digital modulation. What does digital modulation look like? This is also based on these 3 property only, based on amplitude, based on frequency, and based on phase. We can also do digital modulation. Okay, we will see that now. This is about digital modulation. So what happens in digital modulation? We have 3 types again: amplitude, shift key, we say. Then we have frequency shift key. And the third one is phase shift key. These are the three types of digital modulating techniques. Okay. So first one is amplitude shift key. I just make you go through it. The digital signals look like this. Okay, suppose this is the information signal. Okay, so this is the carrier signal and this is the information signal, because we are performing modulation on digital signal. Okay, so the modulated signal will look like this. Okay, when there is 0 it will drop, when there is 1 it will again go, when there is 0 it will drop, when there is 1, when there is 0. Okay, so this is what the modulating signal look like. So this is about amplitude. Okay, based on the amplitude we are encoding the modulating signal. Okay, now based on frequency we have to do this as well. So suppose this is based on frequency, then how it will look like? This was amplitude. When we have 0 we have to take it as, sorry, when we have 1 we have to take it as 1, when we have to take 0 we have to take it as 0. This was about amplitude. Now based on frequency what will happen? So this is 1, high frequency. So when we have 0 we will have low frequency. Okay, when we have 1, high frequency, when we have 0 we have low frequency. The wavelength increases. When we have 1 we have high frequency, when we have 0 we have low frequency. So this is about frequency shift keying. Okay, so based on the frequency we are coding or merging both the signal, that is the modulated signal. The resulted signal is modulated signal. Now based on phase we can also do it. Whenever there is change in phase we have to act accordingly. Okay, so based on phase what happens? It just changes. It just changes. Suppose here there is change in phase, that is there is drop in amplitude. Then what will happen? This will be, the frequency remains same. So continue. Then there is a change, so it will change. Then there is a change, 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 it will change. So this way it happens. So I will show you phase shift keying in a proper manner again, because it has become quite clumsy. So the modulated signals look like this. This is the digital signal. Suppose this, here there is a phase change. Now here there is a phase change. Now here there is a phase change. Now here there is a phase change. So this is how the signal behaves. This is up, this is, then there is a drop, then there is a up, then there is a drop, then there is a up. This way it goes. Okay, so I hope you understood. So this was about modulation. So I will just have a quick revision. See, what is modulation? Low frequency signals cannot travel long distances without losing their strength. To enable them to travel long distances and ultimately reach their destination, we need to enable them through modulation. What is modulation then? Merging carrier wave with information signal in order to enable them to travel long distance is called modulation. Now modulation can be applied on analog signals, digital signals, and so has been reduced as analog modulation and digital modulation. Now based on three properties we can perform modulation, that is amplitude, frequency and phase. In analog modulation we can perform amplitude modulation, frequency modulation and phase modulation based on the above their corresponding properties. Similarly, in digital modulation as well, we perform amplitude shift key, frequency shift key and phase shift key. Okay, so pictorially you have completely understood how it happens. In case you have any doubt, you can post it in the comment section, or you can directly contact me through WhatsApp or through my mail ID. Okay, so this will be all. In the next class we will continue with the next topic, that is cluster cellular system, what a cell is, what is a cluster is, how roaming takes place in case of cellular network. We will discuss all of that. Okay, so thank you, that's all.